Good morning everybody. Today we will discuss about superposition theorem. Previously we have discussed about the maximum power transfer theorem. Now the second theorem is superposition theorem. So what this theorem states about? This theorem can be applied on those networks which network satisfies the following conditions. Number one, the network must be closed. Network must be closed. We will explain about these conditions later on. Now, next condition is, these are the conditions to apply the superposition theorem. Network must be closed. Second one is, network have linear elements. What is linear elements? We will discuss later. Third one, the network must contain more than one source. Okay, these three conditions play vital role to apply the superposition theorem. Okay, so network must be closed. What is that? Suppose we take this network. Here let us take an example. Here two sources V1 and V2 are connected. Three resistances R1, R2 and R3 are connected. The internal resistance of voltage V1 is let R1, small r1, and the internal resistance of the source V2 let small r2. Here the internal resistance are optional, may be present or may be absent. We can neglect. If this present, then we have to take the internal resistances. Okay, the first condition is must be closed network. This is a network or circuit, must be closed. This network is a closed circuit. How do we know that the network is closed or open? That in a closed network, the current must flow through the positive terminal towards the load and again towards the negative terminal. These networks only be closed one. Whether if we have omitted this resistance, then this resistance is replaced as open circuit. Okay, if the linear elements are taken outside or omitted from a network, then the resistances or the linear elements are replaced as open circuit. Okay, if we omit the source, voltage source or current source, if we omit the source, then this can be replaced as short circuit. If we omit the voltage source, then this can be written as short circuit. So this is, if this resistance is omitted, then this is open circuit. So the current flowing from this source or this source cannot pass through these two terminals. Okay, then this network can be named as open network. Now we have replaced the resistance here, so this network is known as closed network. Okay, next, network must have linear elements. What is linear element? Linear elements means linear resistance, linear inductance or linear capacitance. In this case, we can take only the linear resistance. Linear resistance can obey the Ohm's law. Ohm's law. Okay. Linear resistance obeys the Ohm's law. That is, if through the linear resistance, if we flow the current, then the flow of current cannot be changed due to any circumstances. Okay, that resistance is known as linear resistances. Here we have connected three linear elements, that is R1, R2 and R3. Next one is the network must contain more than one source. Okay, this network contains more than one source. Here we have connected voltage 1 and voltage 2. Two sources or DC sources we have connected over here. So this network is fit or is suitable to apply the superposition theorem. Now let us discuss about the statement of the superposition theorem. Statement. What this theorem states or why we apply this theorem. Okay, let us consider this example. Here we have connected two sources. How superposition theorem is applied? Let us see. Here we have connected two sources, V1 and V2. To apply this theorem, we have to consider one source at a time. Okay, one source at a time. So if we consider the voltage source V1, then we have to omit the source V2. If we consider the source V2, then we have to omit the source V1. Here a very important note point is that whether we have omitted the voltage source, then if the internal resistance of this voltage source is present, then we have to take the internal resistance into count. Okay, if we omitted the V1 source, then the internal resistance here R1 is present, so we have to take this internal resistance into count. Okay, if this is omitted, then this source can be replaced as only the resistance small r1. Okay, so at a time we have considered, first we have considered V1 source. Secondly, we have considered the source V2. Then from V1 we get I1, I2 and I3, because here we have to consider three resistances. Let the current flow R1 is I1, R2 is I2 and R3 is I3. Okay, so when we consider voltage source V2, then we have get the three currents again, I1 dash, I2 dash and I3 dash. So our motto to apply superposition theorem is to find the resultant current, in R1, R2 and R3. Okay, from two sources, these three currents must flow through the three resistances R1, R1 equal to R3. But we have to know that how much amount of current will flow through R1, through R2 and through R3. By only applying superposition theorem, we can get the value of currents through R1, R2 and R3. Okay? So by considering this theorem, we have got the resultant current through R1 and R2 and R3. This is the motto to apply superposition theorem. So next we have to study about how we apply the superposition theorem in a closed network. Let us write the statement of superposition theorem in a linear network. In a linear network, containing more than one source, the current which flows at any point is the sum of all the currents which would flow, all the currents which would flow, all the currents which would flow at that point if each source were considered separately and all other sources replaced for time leaving their internal resistance behind. Okay, this is the statement for superposition theorem. Note down this. Now we will discuss about the steps how we apply the superposition theorem into a closed network. Okay. Now example here. Here in the given network we have considered three resistances R1, R2 and R3. Two sources V1 and V2 having their internal resistances R1 and R2. Now this circuit or this network satisfies all the three conditions. Before I have discussed to apply the superposition theorem. Okay. Now step 1. Step 1. How we have applied. In step 1, let us consider V1 source. Let us consider the V1 source. As I have discussed that when we consider the V1 source, then we have to remove the source V2. Then the circuit looks like okay, V1 plus minus R1, R2 and R3. Here small r2 and small r1. The r2 is the internal resistance of source V2. Okay. So how here I1, I2 and I3. These are the three currents flowing through the three corresponding resistances. First, we have to calculate the I1, I2, I3 for the source V1. So, before calculate the currents, we have to calculate the total resistance of this given circuit. As I have discussed in before videos that how we have calculated the total or equivalent resistance of a given circuit. So, if the source is present here, then we have to calculate the equivalent resistance from this side. Okay. So, the current flowing through this direction, so the terminals are plus minus, plus minus, plus minus, plus minus. So, first, the R2 and R2 are in series. R2 series with R2. Okay. Next, these two are in parallel with R3. Parallel with R3. Then these whole resistances are in series with R1. Okay. The whole resistance of these three are series with R1. Okay. Now we have to calculate this value. Then R total 1 is equal to R1 plus R2 into R3 divided by R1 plus R2 plus R3. Sorry, this is R2. This is R2. R2 plus R2 into R3 divided by R2 plus R2 plus R3. Let us say this is M. Okay. So now total R total 1 is equal to M plus this is series with R1 plus series with R1. This R1 and the internal resistance of the source is R1. So this is the total resistance of the circuit for the source V1. Okay. Now let us calculate the currents I1, I2 and I3. I1 is equal to V1 divided by R total 1. I1 is equal to V1 divided by R total 1. Next, I2 is equal to I1 into R3 divided by R2 plus R2 plus R3. This is known as the current division formula. Current division formula. This we will consider this current division formula later on in another video. Then I3 is equal to I2 into R2 plus R2 divided by R2 plus R2 plus R3. R2 plus R2 plus R3. Okay. These three currents are for the source V1. Now let us take step 2. Let us take, this is the current for the source V1. Now we have to take step 2. Then considering V2 source. Okay, considering V2 source. Now this circuit looks like this is V2, this is small r1, r1, r2, r3, this is r2, the internal resistance of source V2. Now likewise we have to take the total resistance or equivalent resistance for this circuit by considering the voltage V2. Now from this side R1 series with R1 parallel with R3, R1 series with R1 parallel with R3, whole series with R2, whole series with R2 and small r2. By calculating this, we get r1 plus r1 into r3 divided by r1 plus r1 plus r3. Let us take this n, say n. So the r total 2 is equal to n plus r2 plus r2. This is r total 2. That is total equivalent resistance for the circuit for the source V2. Now if for this source the three currents I2 dash, I3 dash and I1 dash flowing through these three resistances R1, R2 and R3. So now we have to calculate the values of current for the three resistances. First, I1 dash is equals to I1 dash. Let us take first I2 dash, that is we consider the source V2. Then V2 divided by R total 2. Now I1 dash is equal to I2 into R3 divided by I2 dash into R3 divided by R1 plus R3. Next I3 dash is equal to I2 dash into R1 plus R1 divided by R1 plus R3. These three are the three currents by considering the source V2. Now we have found in step 1 and 2 that the currents are I1, I2 and I3 and I1 dash, I2 dash, I3 dash. I1, I2, I3 are currents for the sources source V1, I1 dash, I2 dash and I3 dash are the three currents for the source V2. Okay. Now in step 3, what happens? In step 3, to find the resultant currents. Find the resultant currents. Resultant current is resultant currents for the resistances. Resultant current for the resistances R1, R2 and R3. R1 I1 minus I1 dash, I2 minus I2 dash, I3 minus I3 dash. We have found all the values for I1, I1 dash, I2, I2 dash, I3, I3 dash. These are the three resultant currents for R1, R2 and R3. Now, there is an important note point that the direction of the resultant currents are in the directions of larger values of currents. That may be, if the larger value is I1 dash, then the direction of current through R1 will be according to this side. If I2 have larger value, then the direction of current R2 will be this direction. If R3 likewise this direction or this direction. Okay. This is all about the superposition theorem.